Introduce the power-on experimental process of the ZT0010 thermal conductivity of building materials measuring instrument. Let's power it on first. There is a switch at the power supply at the back. Turn on the switch. You can see that the power indicator is on. Introduce the temperature setting of this temperature control meter. The set value is shown below and the actual temperature value is shown above. I have set it to 60 degrees now. If I want to set it to 65 degrees according to the experiment, I have to keep pressing the set key for more than 3 seconds. If it is pressed for more than 1 second, it will display SP. After displaying SP, press and hold the up and down keys to adjust the set value. For example, after I adjust it to 61 degrees, I can press the set key again. This is how to adjust the set temperature. Let's do it again. Press and hold the set key and SP will appear. After SP appears, press the up and down keys to adjust the temperature. After adjusting the temperature, press the set key again. The setting value has been changed. After I changed the setting value, I need to turn on the heater. Now the temperature value is set. When it wants to heat, it needs this heating power. So I turn on the heater and start heating. At this time, I open the software at the same time. You can take a look at the display screen of this software. Let me introduce the general principle of this instrument from here. The top layer has been introduced just now. The top layer is the heating plate, and its temperature is controlled by the temperature controller just mentioned. Heat it with a heating rod and control its temperature. Under it is an aluminum plate for heat conduction, and there is a temperature at the bottom edge of the aluminum plate, which is T1. In the middle is the sample plate, and under the sample plate is a copper plate. There is a temperature on the top of the copper plate. Under the copper plate is a heat flux sensor, which is the Q value. Below the heat flux meter is the cold water tank. The cold water tank has the inlet water and outlet water temperature and the temperature of the cold water tank. This shows the temperature of the cold water tank. There is a setting value here from the thickness of the sample plate. Be sure to set this thickness every time you change the sample. This is the thickness setting. There is only one setting value. The value below is a thermal conductivity coefficient. It is calculated based on this temperature difference and this heat flux meter. These two are thermal resistance. The thermal resistance is also measured based on the temperature difference, Q, and this thickness value. Our manual will provide the calculation formula for the K value and R value. I will start the experiment now. We have just set the temperature to 60 degrees. I will turn off the heating first. After opening the door, I put the thermal conductivity material in. This is an acrylic plate. Just put the acrylic plate in and level it with the copper plate. After leveling, turn the hand wheel on top and press it tight. Be careful, this place will be a little hot after heating. Just press it manually and then close the door. Then check the software again. Check the software and the temperature has reached 51 degrees. You can see here that the temperature controller is now 51.6 degrees. It is also 51.6 degrees here. The temperature is the same. It is read through communication, so the two temperatures are the same. Although the temperature is set, it will not heat up if the heater is not turned on. Then I turn on the heater. After a while, you can see through the software that its temperature will slowly rise to 60 degrees, and it has to be stable at around a certain temperature to get experimental data. So this heating process may be very long. Generally, each material is heated If it is heated from a very low temperature to 60 degrees and stabilized, it will take more than half an hour. You can see that the temperature is rising now. It means that it has started to heat now. You can see that during this temperature change process, the K value and R value will be automatically calculated. But the value it calculates now should not be very accurate. Why? Because the value of the heat flow meter now from top to bottom. I just added the experimental materials. The heat has only reached here. It should not be transmitted yet. You can see that the value of this heat flow meter is very low. You can only wait. Because the thermal conductivity of our acrylic board is relatively low, the heat is relatively large, so its heat conduction will be very slow. Generally, it takes at least half an hour from the beginning of heating to the completion of heating to stability. Then wait for 20 minutes and look at the result.